Is my screen visible?
Yes, sir.
Yes, sir.
Yeah. Okay, so we will solve one more example on a nonce way using moment distribution method. First, let me draw that, and you can also just note down this diagram. Okay, so hope you have noted down this diagram. So this is a non-sway frame having a different, each span is having a different moment of inertia. All these moment of inertia values are given here, and all of them are in millimeter raised to 4. And the span CDE is carrying a uniformly distributed load of 6 kilonewton per meter. At C, we have a joint load of 8 kilonewton. Why I'm calling it as a joint load? Because it is acting at the joint. Okay, just a minute. Yes. Okay. Am I audible, right?
Yes, sir.
Yeah.
Yes,
Okay.
sir.
Yes, sir.
Right. And we have a 12 kilonewton joint point load at the center of spans AC. And we have this distributed load of 6 kilonewton per meter is acting throughout span CDE. And there is a point load of 8 kilonewton at joint C also. Now this is a non-sway frame. Easily we can make out because E is fixed one. Okay. Now my question is, if I make E as a pin, will it sway? If I make a support E as a pinned support, will it sway? Yes or no?
No, sir.
No. Okay. Then what kind of support I should make E so that it will sway?
Roller,
No, sir.
Huh? What kind of
roller
support
support,
I
sir.
yeah. If I make E as a roller support, then it will sway. Okay. Now E is a fixed, and if E is a pin support also, then also it will not sway. But if I
Roller.
make yeah, correct. If I make E as a roller support, then it will sway. Okay. Now we'll not worry about that. Just thing is, we know that this frame is a uh, non-sway frame, right? So we have to start with our as usual procedure, that is calculation of distribution factors. First, let me calculate. Okay, at which points you'll calculate distribution factors? Can anybody? Which points you'll calculate distribution factors?
C and D, sir.
Yeah, C and D. A, B,
At
and E.
C.
Yeah, A, B, and E are the end supports, so no need to calculate. So let me calculate at C. So at C, there are two components which are joining, CA and CD. So first, let me calculate distribution factor, that of CA. So that is equal to KCA divided by KCA plus KCD. Okay. So what will happen to KCA? 3A by L or 4A by L?
4 EI by L.
C, far end support A is what kind of support? It is a pinned support. So if it is a pinned support, what I have to use?
3 EI.
Yeah, 3EI 1 by L is 6. So similarly, this is also 3. What
4A by L.
3I by, huh? 4AI by L or 3I by L?
4A by L.
Yeah, it should be 4AI by L because E is an intermediate support. 4EI2 by 8. Now you have to substitute the values of I's and E correctly. So you take that, you assume that E is a constant one. Okay, E is a constant, no need to worry because E gets cancelled. And you have to substitute the I values in millimeter. And similarly, you have to substitute these 6, 8 and 6 in millimeters. Okay, right? So that consistency of units is very much essential. So if you calculate, you'll get DFCA, that is distribution factor, that of CA as 0.6. Now what should be the distribution factor, that of CD? It should be 1 minus 0.6, so that is 0.4. Okay, we calculated at joint C. Let me move on and calculate at joint D now. Okay, so distribution factor DC, let me calculate first. DC is equal to KDC divided by KDC plus KDB plus KDE. Okay, so what will happen to KDC? 4EI by L or 3EI by L?
4A by L.
Yeah, it is actually 4EI2 by 8. This is also 4EI2 by 8. What will be KDB? 3A by L or 4A by L? 3A by L. Okay.
3A by L.
Yeah, correct. It is 3EI3 by 6. What will happen to KDE?
4A by L.
Yeah, it is
4A.
4EI. Yeah, it is 4EI4 divided by 4. Okay. Now once again, I am repeating, substitute the values of I with the consistent units so that you'll get the value of df dc. DC, how much you're getting? Yeah, DC, I think you should be getting 0.24. Okay, then I will calculate that of dB. Distribution factor dB is equal to kdB. Same terms will come, kdc plus kdB plus kDE. So, okay, once you substitute all the things correctly here, I think you should be getting this as 0.28. And the left out one is distribution factor DE, which is equal to 1 minus 0.28 and minus 0.24. So this you're getting 0.48. Students, are you clear with these calculations? Are you clear, students?
Yes, sir.
Yeah. Okay. Once it is done, then I have to draw the table. Let me draw the table here. So first, I will draw that for A. Okay. For A, this is I will draw it for C. Okay. Then I will draw this one for D. There should be double lines because at D, 3 components are joining. So there should be a double line. We'll draw at the end for also I'll draw a horizontal line here. So here I'll be writing the distribution factors. So this line is for A, this line is for C, this line is for D, and this line is for E. So this side it represents AC, this side it represents CA, this side it represents DC, this side it represents DC, this one represents DB. Just let me draw it correctly. This is DB, DE, and ED. Okay, let me write the distribution factors what we have calculated. By default, this will be 1. So these we have calculated as 0.6 and 0.4. This as 0.24 we have calculated, 0.28 we have calculated, 0.48 we have calculated, and this we have calculated as 1. Okay, is this clear, students, till this point?
Yes, sir.
At D, I have purposely drawn double lines because you can see here at D there are 3 components which are joining. So you should draw double lines. After A, I have not drawn B. Okay, you should be very careful. After A, I have drawn C because I need to link between AC and CA. Okay, then after C, I have drawn D. Okay, and at D, I have drawn double line, and after D, I have drawn E. Okay, right. So once this is done, then the next step is to write the fixed end moments. Okay. So what happens to fixed end moment AC? So this 12 kilonewton is acting at exactly at the center. So you should use the formula WL by 8. Okay, and WL by 8, right? This 8 you should not take. I have told earlier also, whenever the loads are acting at the joint, you should not take them into consideration while calculating the fixed end moments. So I will write the values here. So this is -9 plus 9. I will not tell you how to find out these things because you know already. Fixed moment dB is 0 because no load is acting. This is -8 and this is +8. Okay, so once that is done, let me start with my first cycle and the first step, that is balance and distribute. Will you balance A? Before that, let me draw that figure once again so that it will be easy for you to understand. So this is pin support, this is pin support, this is fixed support. This is A, B, C, D, and E. Okay. Now will you balance A? Yes or no?
Yes, sir.
Yeah, because originally it is a pin support. Okay, so you should balance. So underline it. And will you balance C? Yes.
Yes, sir.
Underline that. Will you
Yes, sir.
balance D? Yes, you will underline that. Will you balance E?
No, sir.
No, you should not balance E because E is originally fixed support. So you should not balance that. So the net moment at A at present is -9. To balance that, you will apply +9. +9 into this one is 9. Okay. Now here, if I see the net moment is 9 minus 32, which is -23. So -23 is the net moment at C. To balance that, you will apply +23. +23 you have to distribute according to these distribution factors. So +23 into 0.6 is 13.8. +23 into 0.4 is 9.2. Similarly here, net moment at D is 32, which is 24, is the net moment at D. To balance that, you should apply -24. -24 into 0.24 is -5.76. -24 into 0.28 is -6.72. -24 into 0.48 is -11.52. No need to balance this, so don't worry about that. Then the next step, carry over. Will you carry over from A to C?
Yes, sir.
Yeah, you should carry over from A to C. Will you carry over from C to A?
No, sir.
No, you should not carry over because from C to A you should not carry over. Why? Because A is original pin support. So to the pin support you should not carry over. So 9 divided by 2 is 4.5. Okay, will you carry over for in between these two? Yes, you can carry over because both are intermediate supports. So 9 divided by 9.2 divided by 2 is 4.6 minus 5.76 divided by 2 is -2.88. Okay, and will you carry over from D to B?
No, sir.
No, because B is once again a pin support, so you should not carry over. But will you carry over from D to E? From
Yes,
D
sir.
to E, can you? Yeah, you can carry over because E is a fixed support. Okay, you can carry over. So -11.52 divided by 2 is -5.76. So this completes your first cycle. Students, are you clear?
Yes.
Are you
Yes,
clear?
sir.
Everyone? Everyone?
Yes, sir.
Yeah. Let me move on with my second cycle, balance and distribute. Okay. So you should balance this, underline. You should balance this, underline. No need to balance, so don't underline. So 4.5 minus 2.88, 4.5 minus 2.88 is plus 1.762. So to balance that, you should apply -1.62. -1.62 into 0.6 is -0.972. -1.62 into 0.4 is -2.88. So net moment at D is 4.6. To balance that, you should apply -4.6. -4.6 into 0.24 is -1.104. -4.6 into 0.28 is -1.288. -4 to 0.48 is -0.208. Okay, so nothing to do here. Next step, carry over. So nothing to carry over from this side, so don't worry. Carry over only between these two. -0.552 and from this minus point uh, Okay, did I made a mistake here somewhere? This is not minus. Okay, so this is minus 0.648. Okay, oh yeah, minus 0.648 divided by 2 is minus 0.324. Okay, you can carry over from here to here. Minus 0.104. Students, are you clear with this second cycle? Yes or no?
Yes, sir.
Yeah, so you can carry out one more third cycle and one more fourth cycle. I will not do that part. So I will just leave it to you to do that. So once you're done, so you have to do the summation. I have done already the third and fourth cycles. So this comes out to be 0. So this is coming out to be 26.64. So this is coming out to be minus 26.64. This is 29.58. This is minus 7.95 minus 21.62, and this is 1.21. So this is MAC, MCA, MCD, MDC, MDB, MDE, and MED. Of course, MBD will be 0. So you can see here summation of these two is getting out to be 0, and you can check the net moment of these three will also be 0. Students, are you clear? Any doubt
Yes,
in
sir.
this?
Yes.
Any doubt in this? Any doubt you have?
No, sir.
No, sir.
Okay. Yes. As I told, I have made one video on Kani's method. So that I will upload soon in my YouTube channel, and I will share the link of that. And after this example of moment distribution method, so I actually have to start with the frame problems of sway. So what I will do, I will keep that part at the end, because um, the process is very lengthy and will waste lot of time in that. Okay, so that part I will keep it at the end. Third module, however, I have started with the recorded videos. I will be uploading one video today and tomorrow, like that I will be uploading some 10 to 15 videos, so that parallelly we will complete the third module. And from my next class I will be directly starting with my fourth module, that is flexibility matrix method. Okay, is that clear to everyone? Is that clear, students?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Okay, so
Yes,
if
sir.
you don't, I will stop this here now. So if you don't have any queries,